8.4 similar triangles. In this section, we've already talked about similar triangles, but we're going to get into more specifics. In this question, we're first asked us to write a statement of proportionality. We did that in the last section, but my feeling is we could improve on that. Now, we can do that right from the similarity statement, right? The statement of proportionality. That's where we have three proportions equal to each other. We just kind of match up the corresponding parts of the sides. So looking at this, are these triangles similar? Well, they say they are. Angle L corresponds to angle P. This angle and this angle have to be congruent because the triangles are similar. The sides, these sides, side LM has to be proportional to PQ. LM proportional to PQ. And I'll start with that. LM PQ. Also, MN and QN. MN, notice I put that on top. And because if LM's on top, so does MN. And last, the first and last, LN and PN. The next question is find the measure of angle M and the measure of angle P. M is this angle, and it is corresponding to Q. If I look at Q over here, that's 36 degrees. So the measure of angle M also is 36 degrees. And if you notice, these lines are parallel. These are alternate interior angles. So therefore, they should be congruent to each other. Measure of angle P. Now, P corresponds with the first letter over here, L. So L, we don't know L or P. What do? We're stuck? No. We know this is 36. These angles are vertical angles. I should do this since we're looking for P. So since these angles are vertical, they're congruent. These add up to 142 degrees. And we know all three of these angles add up to 180. So if we take 180 minus the sum of these two angles, we're going to get our total 38 degrees. Now they ask us to find some side lengths. We do know this. We do know this ratio here. Okay, LM, the length of LM is 33. The length of PQ is 30. So we're going to use that ratio now to solve for the missing side length we want, MN. Now MN, so now we find it in this proportion. So MN is what we're looking for. And we need to know QN as well. QN is 20. So now I can solve this problem by cross multiplying and dividing. Once again, you could reduce this down ahead of time to make it easier. Change this problem into divide by 3. You get 11/10 equals x over 20. Now if we multiply and divide, you're going to get x equals 22, which means x is not what we're looking for, but the length of MN is 22. Okay, now we're going to use the same, we already know 33 over 30. This ratio is the same thing as 11 over 10, so I've reduced it once, I'm going to keep it reduced. And this time, we're looking for QM. QM is this whole length. Got to find it on the diagram first. So I really want to know MN. And we already found that. I guess I don't need another proportion. I'm getting ahead of myself. We found this length to be 22. So QM is going to be the sum of that, which is 44. Now, one of the fast ways, this is a time saver, instead of showing, to show triangles are similar, that all the corresponding angles are congruent and all the sides are proportional, when we have a triangle where if two angles of one triangle are congruent to two angles of another, then the two triangles are congruent. So we call this angle-angle similarity postulate. Similar to the congruence postulates we learned back in chapter 4, the angle side angle and side 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 congruence postulates or in theorems. This is the angle-angle similarity postulate. So explain why these triangles are similar. Well, what triangles are similar? Well, this angle is congruent to this angle, so you could say angle WVX, X, make a Z, sorry, WVX, that angle is congruent to angle WZY. What else do we know? Angle W is congruent to angle W. This angle is congruent to itself. That is, these two triangles share that angle. And so since we have these angles are congruent because they're both right angles, this is congruent to itself. That's the reflexive property. So therefore, these triangles are similar by angle-angle similarity. Okay, similarity postulate. One thing that you might have learned, but we can explain it with what we just talked about, is why does a line only have one slope? And if you notice, when you're drawing in these triangles to figure out your slope, so this red triangle, you count over 4, 8, over 10, and you went up 2, 4, 5. So that ratio is rise 5 over 10. Now, this triangle, you went over 4, up 2. So up 2 over 4. The blue triangle, you went over 6, up 3. And I'm saying them backwards, I apologize. But notice these are all the same. And basically why triangles all have the same slope is these sides, these triangles are similar. This triangle has to be similar to this triangle. Okay, the blue and red triangles are similar, and therefore the sides are proportional. And when the sides are proportional, your slopes are going to be the same. One last example here. They asked us to find the length of EH. EH looks like the altitude of this big triangle AEB. And to find it, we want to, well, we're going to have to use similar triangles. And we could say triangle ACD is similar to triangle AEB. I make a similarity statement, and from this statement I could write a similarity, a statement of proportionality, where I set up some proportions that are the same. And in this case, I should explain why these triangles are similar. It doesn't say it in the problem, but if you look, this angle is congruent to this angle, and they share this angle. So we have two angles, so these are similar by angle-angle similarity. From there, we know this base of the small triangle, so we know AD has to be proportional to AB, the base of the big triangle, and the parts, this is an altitude in this triangle, they're going to also, the altitudes will be proportional, and you could go into more detail to prove that, but it's kind of goes off the corresponding parts of congruent triangles are congruent idea. And long story short, we have CF over EH. So plug in the numbers. AD is 5. AB is not 7.5, but it's the sum of the two sides, 12.5. And that's going to equal CF over EH. EH, we don't know. That's what we're looking for. Looking at this, I'm going to try to do it in my head here, so I'm going to double this. With this 10 over 25 over x. And reducing this down, you get 2/5 equals 6 over x. Now when we cross multiply and divide, I can do that in my head. 30 divided by 2 is 15. So segment EH equals 15. There's your homework. If you got questions on them, bring them to class. Write them down now so you know what to ask. See you then.